Just remind you guys what's on the quiz tomorrow, what I put up in class yesterday. Those are all the topics. I'm going to do a couple questions that I did with students yesterday after school for the review, just to be fair. And then whatever questions you guys have, feel free to ask. All right, so the first one I'm going to do, this comes from the tangent and secant worksheet I have up on Classroom. All right, it's the tangent and secant worksheet up on Classroom number 19 that I'm going to do. So I just read through it here. Rm is 2 more than the length of Tm. Rm is 2 more than Tm. So I'm going to call Tmx. 2 more than that is not 2x. It's x plus 2 for Rm. And then it gives me a couple other lengths here. It gives me Qm, which is 2, and Sm, which is 12. Find a couple lengths here for me. Find the length of RT, and then find the length of PS. All right, so I'll start with RT. You guys take a look at that diagram. We call RT a chord in that circle. RT is a chord. So I got to think about, all right, chord. What's the theorem for lengths of a chord? Remember, it's segment times segment equals segment times segment. So if I'm going to find RT, I want to set the following up. Segment RM, x plus 2, times segment MT, x equals, now let's go to chord QS. QM is 2 times MS, which is 12. So that's segment times segment equals segment times segment. Only can be used when two chords are intersecting. Let's solve it. X squared plus 2x equals 24. I see an x squared. I see an x squared in the equation. It's going to be factoring time. Can't factor unless one side is equal to 0. So let's move that 24 over. You will have the quadratic formula available to you tomorrow, either on a reference sheet or if you're taking it at home, it'll be on the top of the formative test. I'm not going to use quadratic formula for this one, absolutely not. Two numbers that multiply to negative 24 but add to 2, positive 6, negative 4. Here we go. X equals negative 6, x equals 4. There's a problem though. If you take a look at segment MT, look at segment MT. I labeled that X. So there's no way it can be negative 6 units long. So I reject negative 6. And this is why I picked this problem out in particular. Everyone, I reject negative 6. My answer is 4. Let's roll on. No, read what I'm asking for here. We're looking for RT. RT is not labeled X. All right. 4 is the length of MT, not RT. Read carefully tomorrow because that's going to happen to some of you. Read carefully. Now let's actually solve this problem. RT will be equal to 4 MT plus 6, which is RM after I plug in 4. It's actually 10. Please watch out for that. All right, read carefully, not only factoring, which will be on there, but reading the question carefully, making sure you answer what is being asked. And then we have to find PS, which is a tangent. I'm just going to label it Y because I already used X. So now how do I find a tangent length? Whole times external equals whole times external. So let's take care of the tangent, which is whole times external, y times itself. Now look at the secant, PTMR. Whole secant length, they gave me PT was 8. There we go. Whole secant length, ready? 8 plus 4 plus 6. So that's going to be 18 for the whole secant length times its external part, 8. So take a look at that. If there's any questions about that, let me know. So finishing this bad boy up, y squared equals 144. Y equals 12. And that is the length of PS. Okay, so great problem because it involved chords, segment times segment equals segment times segment, and it also involves secants and tangents. Whole times external equals whole times external. You will see both tomorrow, definitely. All right, you will see both tomorrow. Anything I can answer on this one here? Again, number 19 from the tangent and secant worksheets. Anything you guys want to ask there before I move on? Okay, another common question that came up in yesterday's after-school review was completing the square to find center and radius. And on Google Classroom, there's a whole bunch of questions like that on the equations of circles worksheet I posted. Whole bunch of them. I just ripped off the last one, number 16. All right, so this is number 16 on the worksheet that says equations of circles on Classroom. All right, so we got to find the center and radius. Right now it's in standard form. I need to complete the square to make it into center radius form. First step, make sure all your x's and y's are on one side of the equal sign and they're together. They're on one side of the equal sign and then they're together. So first thing, add that 8y over. Make sure x's are grouped together, x squared minus 6x, and your y's are grouped together, y squared and 8y. The single number without a variable called the constant has to be on the other side. So right now we are all set and ready to complete the square. All right, so I have x squared minus 6x plus my number I'm going to plug in there to complete the square, plus y squared plus 8y plus number I'll put in there to complete the square equals 56. All right, how do I figure out what that number is? B over 2 all squared. Your B value divided by 2 all squared. So let's start with the x's. I take negative 6 divided by 2, negative 3, square it, 9. So let me let somebody in here real quick. Hold on. All right, next up, do it for the y's now. 8 divided by 2 is 4, 4 squared, we get 16. Now, number 1, kids forget this next step. Number 2, they do it incorrectly if they do remember it. Whatever you add to the left, you have to add to the right to keep it balanced. So you notice I added 9 and 16. Add 9 and 16. Don't add the opposite. Add the same thing you did to the left to the right. A lot of kids will add negative 9 and negative 16 like they're trying to move it over. No. You're just making it balanced now. So whatever you add to the left, add to the right. All right, next up, completing the square. So I have step 1, rearrange. Step 2, find the number to add. Step 3, complete the square now. I'm going to do this all out. I know some of you may know what the trick is to finish this pretty quickly. I'm going to do it all the way out. So I'm going to take this first grouping right here of the x's and factor that. 2 numbers that multiply to 9 but add to negative 6. And they should be the same darn numbers that multiply to 9 and add to negative 6. It's minus 3, minus 3. So when I rewrite that, it's going to be x minus 3 all squared. Plus, now take the grouping on the y's. Factor. 2 numbers that multiply to 16 but add to 8. Same numbers. They should be the same numbers. And in this case, y plus 4, y plus 4. y plus 4 all squared. Now, I said before, some of you guys may know the trick. If you don't want to factor like I just did off to the side to figure out what should go in the parenthesis, it's always b divided by 2. So negative 6 divided by 2, that's how I got negative 3. 8 divided by 2 for the y's, that's how I got 4. But if you're, it's one less thing to remember, go ahead and factor it then. And then over here, 56 plus 9 plus 16, let's see, 20, 81. Okay, so there's my circle equation the way I like it. Now you got to have the ability to pull the center and the radius out now. Center. Let me just write underneath what the circle equation is, and hopefully that'll be helpful. Let's see, blue, haven't done that yet. X minus h squared plus y minus k squared equals r squared. So what's in place of h? Positive 3. Because remember, it's already x minus, and the only thing I plugged in for h was 3. And now how did I get a positive 4 in there? I must have plugged in a negative 4 for k. And then radius length, not 81, not 81. That's the radius length squared. Hey, r squared equals 81. So your radius must be 9. All right. So there's a completing the square to find the center and the radius. Sure, all of you guys could do that a little quicker, but I just wanted to make sure we go step by step by step to see where everything comes from there. All right. I have one more thing I want to do with you, but I'll open it up for questions now, so I make sure I get those taken care of first. Specific questions you guys have for me that you want to go over?
I have a question about number 23 in the packet.
Okay, let me get the packet up. Go ahead.
I just needed help finding angle ABC. I couldn't figure out how to do that.
ADC. Got it. All right, so let me, you got all the arc measures first?
Yeah.
Okay, good. Because that'll make this a lot quicker then, if you have all the arc measures. $23 out of the packet, everybody. All right, I'm trusting you here. What arc AD? What's the measure?
AD is 140.
DB.
40.
EB.
140 again.
And then 40 for AE?
Yeah.
Okay. So the question is, last question here. What is ADC? All right. If I take a look at ADC, let me highlight it real quick. Angle ADC. It's not inside. It's not outside. Half of it's outside. Half of it's inside. But look how it's formed. All right. AD. That's a chord. And DC, that's a tangent. All right, we have a rule for an angle formed by a chord and a tangent. And the rule is I take half the arc in between it. If an angle is formed by a chord and a tangent, I take half the arc in between, which would be, in my case, AEBD, that arc right there. So all I need to do is add up all the arcs that make it, which would be 40, 140, and 40, which would be, let's see, that's 80, 220. So I'm going to take half of 220. So that's going to be 110 degrees. So any angle formed by a chord and a tangent, I'm always going to take half the arc that's in between it.
Thank you.
Yeah. Other questions? Anything specific? Ask away. All right, so what I was going to do too, and I did this yesterday, and I always like just to be fair to both review days, I I did a Zach started it here. I did a multi-part circle question with the kids yesterday after class. So I'm just going to go to on Classroom. I have a worksheet that says multi-part circle questions. There's, give me a break. There we go. Is this my 42 one here? Nope, only 23 of these. Okay, so I must have posted a new one. All right, so there's 23 of these. Zach, let me go back to you. You asked the last question. Give me a number here, 1 through 23. Oh, he left it. Then there's only 2 of you. All right, no problem. Colin, want to give me a number 1 through 23 here? Okay. Malia, you want to give me one, Malia?
Sure.
Oh, no problem, Colin. Sorry. Go ahead, Malia.
12.
12. Okay. Oh boy, part A and B. All right, gonna be on my toes here. Okay, let's do this. All right, here we go. And tomorrow, and I can tell you, I'll tell you guys right now. Tomorrow, expect the arcs to be in a certain ratio, and you got to do something with the ratio. Set it equal to 180, 360, whatever the arcs add up to. All right, so be prepared for that. This one right away says arc AB and arc BE are in a ratio of 2 to 1. So I got 2x and I got x right here. What can I do with those two in particular? I can add them up and set them equal to, it tells me that AOE is a diameter AE, so I can set them equal to 180, a semicircle. 3x equals 180, x equals 60. So I can say arc BE is 60, arc AB is 60, 120. And the only other arc is the 180 degree arc. All right, let's do this. Part A, arc AB, we already found. That's $120. How about B? Angle BAC. BAC, that looks like it's inscribed to me. Angle BAC, inscribed. So I take half the arc in between, which would be 60. So that's going to be 30 degrees. Let me plug that in, may need it later. 30 degrees. Next up, angle C. Angle C is on the outside, and we know the rule for the outside angle is half of 2 arcs subtracted. And this 2 arcs in between are the ones we've been working with, 120 and 60. Half of 60, 30. Let's see, where's that angle? Right here, 30, angle C. And then what else do I have? Angle ABC. All right, that's the one that Zach just asked before he left and made this awkward for me. Angle ABC. Again, half of it's inside, half of it's outside, but it is a chord and a tangent. AB is the chord, BC is the tangent. So I'm going to take half the arc in between. Always helps me to highlight the arc in between. So A, B, C. It's the 180 degree semicircle and the 60 degree arc. So total 240. So I end up with 120 degrees for angle ABC. So I figured out everything in part A. Ooh, here we go. Is triangle OBC acute, right, obtuse, or equiangular? All right, well, I know all 3 angles in there now, 30, 30, and 120. since it is a 120-degree angle there, that makes this bad boy obtuse. All right. Oh, OB, hold on. OBC, hold on. I was doing ABC. OBC. This triangle right here. Okay, well, let's figure it out. I know one angle's already 30, right? And then another angle I can find is the central angle, BOE. Central angle is equal to its arc, so this is going to be 60, because arc BE is 60, and they're always equal. And that would make the remaining angle 30, 60, 90. So this is a right triangle. Oh, I should have put this one in the quiz tomorrow. I like that. All right, so that's got to be a right triangle.
How many proofs are going to be on the quiz tomorrow?
Just one. And it'll be, proving triangles congruent, CPCTC, or proving triangles similar, CSSTP, product of the means equals product of the extremes. Along with all your circle theorems that we've used. So definitely take a look at the 3 proofs we did in class on Friday and the 3 you had over the weekend. Anything else from you two you would like on this personal review session? Go ahead and ask away if you have anything. All right. If there's nothing at all, I don't think I'm missing anything. Everything I put up on the topics here is going to be on there. Circle equations, chords intersecting, tangent secants, complete the square to find the center and radius, multi-part question like we just went over, and then your proof. So there's your quiz tomorrow. Last call, anything else? All righty. Email me tonight if you guys come up with extra questions. If not, good luck tomorrow morning. Thanks for stopping by, guys.